Mr. Wright here, and welcome to this first set of IGCSE questions involving differentiation. Differentiation is a key topic for those of you going for the top grade. There are 3 questions in this set. Take the time to understand what you're doing in depth. If you've got any questions, leave me a comment, and of course I'll respond. And look out for further films in this differentiation playlist. Thanks for watching. Good luck. Question 1. I've got a cuboid here, and I'm told the total surface area of the cuboid is A square centimetres. And I need to find the maximum value of A. Let's start out by writing an expression for the surface area A. So A is going to equal, well, I've got the top and the bottom of the cube, so that's an area of 2x squared. And then I've got the 4 sides, and the 4 sides are all the same, so it's going to be 4 multiplied by, now the area of one of the sides is x multiplied by 12 minus 3x. So there's an expression for the surface area of the cuboid, and I can simplify that. 48x minus 12x squared, and again I can simplify that, minus 10x squared plus 48x. Now I'm asked to find the maximum value of A, so I'd like to know how A changes with x. So I'm going to differentiate A with respect to x. So I'm differentiating this expression here. So I'm going to differentiate minus 10x squared. So I have 2 times the minus 10 is minus 20, and then subtract 1 from the power, so it's just x to the 1. Plus, now 48x, remember that's an x to the 1 there. 1 times 48 is 48. X to the 0 is just 1. So there is my differentiated A. So that shows me how A changes when x changes. And I want a maximum value of A. So I want to know what value of x gives me a maximum. So what value of x makes the differential equal to 0. So I'm going to solve that equation. Solve that equation, quite straightforward to solve, and you will find that x is 2.4. So now I know what value of x gives me the maximum value of A. I can get on and find out what that maximum value of A is by substituting x into my formula for the surface area. So I'm going to do that now. I know that my surface area is, I know that A is minus 10 times x squared plus 48x, and I know that x is 2.4. So if I substitute 2.4 in here, let's show the examiner what I'm doing. Stick that into my calculator, I find that the maximum surface area is 57.6 square centimetres. And that is my solution for question 1. Question 2. I've got a 5-sided shape here, and I'm told that it's made up of a rectangle and an equilateral triangle. So that's length y, and those are length x. I'm told that the perimeter of the shape is 100 centimetres. So straight away I can write down that 3x plus 2y equals 100. Great. Now I'm told that the area is r square centimetres, and I'm asked to show that r is equal to that expression there. So what I'm going to do is I'm going to get my own expression for r, first of all. So what is the area of this shape going to be? Well, it's a rectangle, which has an area of xy, and an equilateral triangle. Now, the equilateral triangle looks like this. It doesn't look very much like that, but still, that'll do. Okay, x and x and x, and it's got a height. Right, so I need to find the area of that triangle. So it's going to be half the base multiplied by the height. And to find the height, I'm going to use Pythagoras. So the height is going to be x squared, square the hypotenuse, minus x over 2 squared, because that length there is half of x despite my rubbish drawing. So let's simplify this, shall we? xy plus x over 2 multiplied by the square root of, well, x over 2 squared is x squared over 4. So I've got an x squared minus a quarter of x squared. So that's going to give me 3 over 4 times x squared, 3/4 of x squared. Let's carry on. xy plus x over 2 times root 3 over 2 times by x. Great. Carry on. xy plus root 3 over 4 x squared. Okay, there's an expression for r which I've come up with, and we can see the expression which they have provided me with in the question. I see the expression that I'm aiming for, the one on the left, it doesn't have any y's in it. So I obviously need to substitute y out of my expression here. Now to do that, I'm going to use my first equation top left here, because this tells me that 2y is 100 minus 3x, so y is 50 minus 3 over 2x. So I'm going to substitute this expression in for y. So that's going to mean that r is x multiplied by 50 minus 3 over 2x plus root 3 over 4 x squared. Multiply out the bracket. 50x minus 3 over 2 x squared plus root 3 over 4 x squared. Now, often in questions like this, you face a choice at this point. I can continue manipulating my expression on the right-hand side until I make it equal to the expression in the question, or I can manipulate the expression in the question and make it equal to what I've come up with so far and make the two expressions meet in the middle, if you like. And I'm going to do the latter one. So the expression in the question so far is r equals x over 4 multiplied by 200 minus open bracket 6 minus root 3 close bracket x close bracket. Be very careful with your signs. Let's multiply that out. X over 4 times 200 is 50x. It's looking like my expression already. Now, x over 4, let's just keep it simple, shall we? X over 4 multiplied by the bracket multiplied by x. I'm just doing one thing at a time. I don't want to mess up those signs. 50x. Now I've got minus a quarter, so minus. I've got x over 4 times 6. And then times x at the end. Don't forget about that x there. So I'm going to have 6 over 4 x squared. Now I've got a minus times a minus is a plus. I've got root 3 over 4 and then x squared. And would you look at that? My expression on the left is so close to the expression I'm aiming for on the right. In fact, all I need to do is to simplify that fraction. And there we go. So these two expressions are equal. So I have shown that r does indeed equal the expression which I was given in the question. And there is part A complete. Part B. Find the value of x for which r has its maximum value. Give your answer in this form. Okay, where p and q are integers, right? I've got here my expression for r in terms of x, which I've copied across from part A. And I need to differentiate this with respect to x, and then set that differential to 0 in order to find the value of x, which gives r its maximum value, or gives a stationary point anyway. So I'm differentiating this expression 50x. Well, that's 50x to the power 1, so the differential of that is just 50 times x to the power of 0, which is simply 50, minus x squared, so 2 times minus 3 over 2 is minus 3, x to the power of 1, because I've reduced the power of x by 1, plus I've got x squared here, so I'm going to do twice the coefficient. Well, twice root 3 over 4 is root 3 over 2. And that's going to be multiplied by x because I've reduced the power of x by 1. So that is my differential there. And I'm going to find the value of x, which makes that a maximum, by setting this differential equal to 0 and finding the value of x, which makes the differential equal to 0. Let's multiply everything by 2. 100 minus 6x plus root 3x equals 0. Okay, let's stick everything with an x on one side. So I've got root 3x minus 6x here equals minus 100 there. Okay, now let's change the sign left and right. Multiply this side by minus 1 and multiply that side by minus 1. Okay, now I need to make x a subject, so I'm going to factorize and then divide. Remember, factorize and divide. I'm fadding it. So x will be 100 over 6 minus root 3. Now let's see. In the question here, it says I must give the answer in the form p over q minus root 3, where p and q are integers. Well, I've done that, haven't I? So that is my answer to B part 1. Find the value of x for which r has its maximum value. I've done that. Good. Part B, part 2. Explain why the maximum value of r is given by this value of x. Let me just take a moment to make sure that you're clear on what the question is asking you here. What we've done is we've had an expression for r, and we've differentiated that and found that it has a stationary point at that value of x. But the problem is, of course, that if the function of r looks like this, then the stationary point is a minimum, not a maximum. Whereas if the value of r looks like that, then the stationary point would be a maximum. And what the question is asking you is, how do you know that we're dealing with a function that looks like this one? So this is a maximum rather than a function that looks like that one. So to answer the question, you need to explain that in our function r, we have a negative coefficient on the x squared. Therefore, we are dealing with a curve which is shaped like this, and therefore the stationary point is a maximum. And that is how to approach that question. Right, question 3. We've got a diagram with a sketch of part of the curve with this equation, y equals x squared minus p over x. I'm going to write that as p multiplied by x to the power of minus 1, where p is a constant. For all the values of p, the curve has exactly one turning point, and there it is, look. And this turning point is the minimum, shown as the point t. For the curve where the x-coordinate of t, the x-coordinate of the minimum is minus 3, find the value of p. Now, if the x-coordinate of the minimum is minus 3, then the differential, dy by dx, must equal 0 when x equals minus 3. So all I need to do is to find the differential and set p so that the differential equals 0 when x is minus 3. Let's start off by finding the differential of y. Now I know that y equals x squared minus p x to the minus 1. So I'm going to differentiate y with respect to x. That's x squared, so 2 times the coefficient of x. 2 times 1 is 2 times x to the power of 1. Subtract 1 from the power. Right, this second expression, I've got a power of minus 1 and I've got a coefficient of minus p. So minus 1 times minus p, that's going to be plus p x to the power of minus 2, subtracting 1 from the power. So that's my differential. And I know that this differential equals 0 when x is minus 3, because minus 3 is the x-coordinate of the minimum. So I'm just going to substitute in x is minus 3 into this. So I'm going to have not 2 times x, but 2 times minus 3 plus p over, not x to the power of minus 2, but minus 3 to the power of minus 2, which is going to be p over 9 equals 0. So that's minus 6 plus p over 9 equals 0. So p over 9 equals 6. So p must be 54. 6 9 is 54. So find the value of p. I've done that, and p is 54. That's part A complete. Okay, part B. I've got a line with equation y equals k, and that's tangent to this curve here. And I need to find out where that is. Let's draw a diagram. Here's a set of coordinate axes. I've got the line y equals k. I don't know where k is, but let's imagine that that is the line y equals k, which would mean that that is k there. Okay. So this curve is going to be something like this, isn't it? Now, if that line y equals k is a tangent, it must touch the curve at a maximum, mustn't it? So really what I'm being asked to find is, where is that maximum? Or specifically, what's the y value of that maximum, the y coordinate of that maximum point? So we need to find the maximum of this curve. The curve we need to find the maximum of is y equals x squared minus 16 times x to the power of minus 1. So I'm going to start by differentiating that, because then I can set the differential of the gradient function equal to 0 to find the x-coordinate of the maximum. So let's differentiate this. Differential of x squared is 2x. Now I've got minus 16. I need to multiply that by minus 1. Gives me plus 16, x to the power of not minus 1 anymore, but minus 2. So that is my gradient function. And so I need to solve this equation. I need to find out what value of x makes my gradient function equal to 0. So I'm going to multiply everything by x squared. Gives me 2x cubed plus 16 equals 0. So 2x cubed equals minus 16. So x cubed equals minus 8. So x is the cube root of minus 8 minus 2. So I can see now that that x-coordinate is minus 2. I appreciate the y-axis is in the wrong place, but it doesn't matter. Now, I'm asked to find the value of k, so I need the y-coordinate at that point. So I'm going to need to go back to the equation of the curve, and I need to substitute in x equals minus 2 and find what y is. Well, minus 2 squared is simply 4 minus 16 over minus 2. So that is going to be 4 plus 8, which gives me a y-coordinate of 12. So this line here, the line y equals k, must be the line y equals 12. The question says find the value of k. So my answer is that k is 12. And that is that question complete. Okay, that's the end of those 3 IGCSE exam questions. You will find more video walkthroughs of differentiation questions later on in this playlist. Any questions, please do leave me a comment, and of course I'll respond. And please, if you're finding these films useful, please hit like. And if you want to see more of the same sort of content, then subscribe. Good luck. See you in the next film.